So, good morning. So, we will start from lecture 12, that is establishing zero waste biorefinery for crustaceans and shellfish. So, what is the protocol for establishing a biorefinery? First, we need to know about the biomass, what are its properties and what are its requirement. That means how to stabilize it, how to preserve it, and then second one, what is your target bioproduct, what you want to achieve out of it and what is the specification of that. Yeah. Then you make the inventory of processes and the product and the technologies. Then you try to club it together and then to make the process workable and then do your cost benefit analysis. Take an example of if you have to assemble a computer or assemble a car. Yeah. Car is having multiple engines, you have tires, you have engine, you have fuel delivery system, fuel tank, yeah, and output is efficiency and all those things. So, how you assemble that, very similar approach is for biorefinery. So, I was talking about lumpfish or the small fish which is used to eat lysis in salmon aquaculture farm. So, they look something like this, as you can see small blue fish, yeah. So, these are the small fish which are used till certain weight and each and every species is manually vaccinated so that they do not impart disease into aquaculture farm. And after that they are also known as cull fish. That means once their job is done, they are either killed or if you leave it into open water and they go big. Yeah. So, again there is one short video or short of presentation here which shows how we can use the whole lumpfish itself for valorization purposes. So, whole fish is grounded, added alkali, centrifuged, then you get lipid on the surface. Yeah. After that, if you remove the oil, because this contains very low amount of oil, you hardly see anything. Protein precipitated with a hydrochloric acid, and this is what you are going to do pretty much today. You already have biomass here, and then after that whatever is left over residue is the collagen extraction. So, collagen extraction is acid soluble fraction of the protein and then you get slightly whitish in color. Yeah. And then as you can see collagen is started precipitating and this is the white color collagen what you get. Yeah. So, in this is what pretty much of the biomass, whether you use a whole biomass or you use a side stream, is both the same thing. Fish, you add an alkali to extract the protein, you have residue, alkali whatever you extracted, adjust the pH to 4.5, 5.5 or 3.5 depending upon isoelectric point and then protein precipitates, that is A protein. Leftover residue, you wash it to remove the acid, to remove alkali and then you add acid to it, do again the extraction, now you get acid soluble protein. That is why I mentioned Osborne classification. Yeah. Majority of the protein is alkali soluble, that is why half of the reference in literature is alkali extraction, that is sodium hydroxide. pH 8 to 12 and you adjust the pH. It is not you have to make a solution of 0.1 molar and then add to it, or else even if you are adding a water and you adjust the pH between this area. Yeah. That is the purpose. Either you make a solution, add the stuff to it, or if you have water added in and adjust the pH to 8 to 12. Always adjustment of pH is done either by 0.1 molar or 0.2 molar, not to use very high level of acid. Yeah. You can use higher level of concentration of acid provided you are just using it for adjustment of pH. Yeah. So, this is what we pretty much covered other day, and then you have different technologies, whether you use it for during collagen extraction or you use it during protein extraction, or if it is having high lipid, so you have to remove the lipid first. Some of the suggestions came in other day for using microwave to separate the lipid or squeezing it or to cooking the whole biomass. to separate the lipid and subsequent extraction processes. Yeah, there are multiple options are there. And when you do research, you investigate number of different options and then come out with the best solution. Yeah, this is very similar if many of you travel to Rourkela for the first time. So, how many routes were there from Chennai to Rourkela? 10 different ways of coming here. Easiest and cheapest one was walking all the way from Chennai to Rourkela. Most expensive one was to hire a private chopper and land straight into Rourkela. Yeah, walking, economical, time consuming, conventional process. Hiring an helicopter, landing into Rourkela, quickest 35 minutes and most expensive. Yeah. So, all those things are exactly the same way. It is not that somebody is doing PhD and or completed a PhD or a postdoc or a professor, they are only researcher. Everybody is a researcher and at some point or the other. Yeah. Okay. So, that is one. Now, again coming back to the same stuff of fish biorefinery or seafood biorefinery, is one is how do you have a fish? You can preserve it by using a salting technique. Many of you who are aware of seafood at domestic level or at you have seen in the coastal places, sun drying, as I mentioned, you dry the whole fish, yeah, then separate the oil and then powdering it to get the protein. That is another way, that is dry way of doing it, and I will cover this one when we go into ingredients and products and technologies. Smoking, long, hot and cold, these are all different techniques how the fish is processed. Rapid freezing, that is at lower temperature, or cold storage. Yeah. And then you have a number of different new techniques, and some of these techniques we will be covering it as we move forward. Whether it is cold plasma, you have seen the demonstration of cold plasma. So, I will cover the full theoretical part and lectures related to cold plasma, how different applications can be made. Some references for ultrasonics. Irradiation, we will not cover it because you would have studied a lot about food irradiation, gamma irradiation and other places. Some countries they do not or some consumers they do not like radiation, and in India there is a Bhabha Atomic Research Center where a lot of food radiation work is carried out, and that is one. Bit on pulse electric field, high pressure, and some of those alternative to chlorine. And this is again the very simple process. You have fish waste or discards, you make silage or you preserve it, that is stabilization of biomass, and then after that you go for extraction process. Yeah. So, establishing a technology for biorefining or bioprocessing, biomass, stabilization, stroke pretreatment or extraction, and then you have end product. So, this is all what you get different side stream and how it can be carried out. So, number of different techniques are there, and half of those techniques have been traditionally used for non-fish application, but you can replicate them on seafood. Now, coming to the shells. Yeah. So, if you look at the shells, these are the statistics, and if you remember lecture number 8 or 9 when we are talking about waste valorization. First one is to quantify waste and see how much waste is available and how what all can be extracted. So, these are the statistics as I mentioned earlier from BIM boardishmara.ie. This is Irish Seafood Board, yeah, which estimates all the waste processing and help different industry to run those businesses. So, contribution is euro 1.3 billion for GDP for Irish seafood industry, and you can see number of companies, number of processors and number of aquaculture sites and total number of people employed. Yeah. For given size of the country, this is quite big numbers. Yeah. And where are the majority of activities located? Now, with this the type of side stream comes is only the shells which does not contain chitin chitosan. This is a bigger problem because how do we dispose them? Because small amount of meat is attached between those two shells, and because of that it is classified as category 3 waste. That means which can create disease and can have lot of food poisoning. So, it has to be discarded according to a certain regulations, very similar to dead animals. If you are working in veterinary and dairy farm, there is dead animal, how do you dispose that dead animal? You do not recover ingredients out of it. Yeah, it's very similar, but till the time it is in food processing plant, it is still a food ingredient. The moment it comes out, it is a waste, then goes through a completely different regulation. It is very similar till the time you are eating a pizza, half eaten pizza, you keep it in a plate, it is still a food. The moment you put it in a bin, even your bin is having all other food item, you see it as a waste. Yeah, similar example. And then you have scallops, shells. So, it says sales volume, production units and amount of waste they generated. If you take the quantity, where is the quantity written? If you take total quantity in terms of values, the waste generated it enormous. Yeah, if it is 30% is wasted, 30 to 50% is wasted in terms of metal, you can think how much of waste is generated. Yeah. So, that is one, and then this shows the shrimp processing, what you have done a bit, and this is done with our own postdoc. He is working on that particular Impress EU project. This is the final product what is left over. If you will see, okay, I will just mute this volume. This is done in a lab over there, very similar what you guys were doing. Shrimp added in with, here the work was done with acetic acid or pepsin, the number of different enzyme options are there. So, after that, and this is actually demineralization carried out by using hydrochloric acid and ultrasound. This is ultrasonic system which was carried out to improve process efficiency, deacetylation, that is again 50% NOH high temperature, and then you are left over this product as a chitosan. Yeah, and whatever water was coming out of it, that is again for the protein, and if you will see, it is not very clear here, this white droplets, these are the protein which will be precipitated for obtaining protein, and leftover water is going to go to our other partner to grow duckweed on that particular biomass. Yeah, or to grow microalgae. So, whatever comes out the best one, and that will establish complete biorefinery, blue circular economy. Yeah. So, what you are saying is really application, similar type of experiment what you are doing over here. So, that is another one is whelk shells, that is again the snails. Yeah. How many of you eat snails? Okay. So, snails are eaten as different forms, like whole snail is cooked and muscle is separated. The waste is shells, and these shells, they do not contain chitin or chitosan, they contain very small quantity of chitin. If you will see here, shells, this is exactly what you guys carried out here. Yeah. Well, this is again from our lab, and then is incubation with NaOH or alkalis. Here the stuff is reversed. Yeah, that means alkali is used or protease enzymes are used. That means deproteinization first, followed by removal of minerals. So, it can be either way. Yeah, separation and washing, and he is a postdoc from Indonesia. His name is Chandra. Yeah. And then once I will just move a bit faster. Oh, sorry. So, once you separate it, then we are extracting the protein, whether shell contains chitin or very small point of chitin or a protein, that depends how strong the shells will be. And this is what you will see, you are seeing all the bubbles, how these shells were completely dissolved. Yeah, and there some special stuffs were added in, and within shorter duration, this was completely dissolved like that. Yeah, this you won't have seen this one complete dissolution when you were doing the experiments here. Can you guess the reason? Don't say the acid is different. No, not because of that. The reason was because it was not having much of chitin or a protein. Whereas prawn shells or your shrimp shells or crab shells, they are harder, they have large amount of protein and chitin in their network. That is why you will see lot of that material. That is why it was bit more flexible, not hard, and that is the way you can obtain the calcium. And I think the ingredient, if it is right, so you will have calcium chloride or calcium acetate, whatever acid was used. Yeah. So, it is the simple process, and then how you improve the process, that again depends upon application of different technologies. So, I am coming back to the slides which we covered briefly before on shrimp. Harvesting, storage, your pre-treatment stuff, thawing and washing, again stabilization, pre-treatment, cooking and market. Wastewater, drying, milling, demineralization, deproteinization and deacetylation. Yeah. I tend to repeat a process so many times so that you will remember by heart, then you do not have to write it and do it. Yeah. And then to improve these two processes, either use ultrasonics, microwave or combination of these technology, use fermentation or enzymes. So, even you can use microorganisms which can eat those proteins or eat those chitin, that is chitinase, if you are interested only in the protein side of it. So, there are a number of ways of doing it, and these two processes can be named as biological processes, yeah, compared to mechanical, chemical or physical methods. So, you can get chitosan. So, this is what you saw, that white color box, chitosan, how much was obtained from 1 kg of biomass. Yeah. What are the side streams you are getting? Mineral rich extract, the water which is left over will contain certain nutrients and certain heavy metals. So, that is fractionated to see whether it is usable or it has to be discarded. Protein rich powder to obtain shell's protein, and if you make a peptides out of it, and these peptides have very good bone recovery and bone properties, bone that is all joint health and all those type of anti-inflammatory properties are there, because they are coming in with from shells and they have a strong binding with proteins and potassium or phosphorus within the bone structure, and you have a strong alkaline water, which you get your proteins, minerals and pigments. The reason why pigment step was removed even from the shrimp, what you saw in a short video, the reason was the moment we remove pigment, we need to add certain organic solvents. The purpose here was mainly to target chitosan and protein plus minerals. Yeah. If we have to go through the pigmentation route, then we have to use through supercritical or some other technique if the intention is to get the pectin. Yeah. So, in biorefinery, it all depends upon what type of main products you want. Yeah. So, with this talks about your shrimp. So, if you will see here, all the water which is coming either from the shells or from cooking, all these things can be valorized. So, as you can see there, in reality how the circularity is added into different process line. Yeah. Majority of the literature what you will see for chitosan production, it says shells were obtained from A, B and C, clean shells, freeze dried or milled shells and chitin yield. There is no reference of what is done with the wastewater, what is done with the protein and other one. Yeah. But now the shift has focused towards zero waste and establishing complete biorefinery, valorizing every biomass whatever is produced along the chain. So, that is why system is slightly changing. So, this is one. Second one is related to crabs. Yeah. In terms of crab, whether crab is whole crab itself is a waste, this is again repeat of what you saw briefly previously, right. And then you have a processing where you have for direct commercial sale, that is simple. Unusable ones you get different processes to obtain different products. Yeah. So, do you have any questions? It is quite similar, only the biomass is different. Any questions or any doubt you have? Because when I start asking questions, then it will be a bit of problem. Yeah. So, if you have a crab, whole crab along with the shells, you recover meat. If it is of not the best quality, it's best for feed or animal purpose. White meat, processed, fresh, frozen, pasteurized or canned. That is normal product what you get. Other one, mixed meat, brown meat, tertiary processing, ingredient for paste, pate, snacks or cakes or different product. This is all your product development side of it. Other shells which are not used, you mechanically or separated, because here your intention is to crush everything, or directly to use a protease enzyme into unsaleable crabs and get the protein hydrosolate out of it. That will be the easiest way of separating the shells with the liquid biomass, that is protein. And then you have clean shells, and then you go for chitosan production. Yeah. And how many of you eat crabs? Whole crab, processed and cooked. Yeah. So, based on that, you can again go for simple process for extracting chitosan. So, as you can see, chitosan can be as high as 14% of dry shell. Yeah, is a quite significant amount of chitosan you can get out of dry shells. Yeah. So, if you do not have any question, I will move forward. Now, this is the third shell, that is whelk or snails, and lot of snail farms are there. And I will be very honest, before this I was not knowing that snails are also processed. I was knowing in seafood only fish. I am talking about 7-8 years ago. When you go into different coastal areas, then you will see what all has been processed and what all has been consumed. The simple process for whelk is obtained, they are washed, manually segregated. Any shells which is having some strains or something on the surfaces, as you would have seen when you go to the beach to collect nice looking snails, or what do you call that, out of shunk, what do you call that? Shunk, right? Okay, the same word in every language, good. The shunk, and some places they have white tiny spots are there on them because of different damages. Those shells are discarded. Yeah, that accounts for 10 to 20%, in some cases up to 30% of those shells along with meat are discarded. Then that is, meat is removed either by cooking or by cooking in a brine solution. Yeah. And that meat is sold in a market. So, the waste product here is your shells, which also contains almost bit of meat, shells and some meat residue. As you can see, this is a snail and meat is recovered. The guys who are working on this, they only love seafood. Yeah, he's so keen in getting all the meat, any extra meat he extracts it and is happy for that. So, this much of quantity is processed every year. Yeah. Out of that, 20% of meat and this much amount of shells and residue goes as a waste. You can see the amount of quantity it is having there, right? And then in these processes you have a cooked wastewater, and when it comes to cooked wastewater, this contains salt plus meat in it. Yeah. The process was handed over to industry as whelk, STOCK, stock cubes. How many of you have used stock cubes? Small vegetable cubes are sold in a market. You just add it into the curry to get the flavor. Yeah, small Knorr and different brands vegetable cubes are there. Similar way, stock cubes are available for different products. So, all the salt solution can be obtained here. Other one is cooked water going through a membranes processing. Yeah. So, membrane processing to segregate the protein based on your ultrafiltration, microfiltration, nanofiltration or reverse osmosis. Yeah. Microfiltration is something like sieving to a micron level. The normal sieves are also 10 micron, 15 micron, and some of you would have used HPLC or so, they are 0.25 micron filters. So, that is the membrane. So, microfiltration get rid of all the large chunk of protein. Then you go for ultrafiltration, but this is done after microfiltration, where you can separate based on the molecular weight. Proteins, what is the molecular weight range of proteins? They are pretty much more than 50 kilodalton and up to 100, 200 kilodalton. So, that proteins are separated. Then you have your peptides and then bioactives, and the salt molecular weight is in just few daltons. Yeah. So, based on that, biorefinery process can be established. Any questions so far? So, in a similar fashion, whatever you obtain with a wash water or a side stream, you still have protein or lipid, and this water goes for duckweed cultivation. So, this some of the details of all these work, which is ongoing, and ongoing in the sense lot of research has already been carried out, lot is already there in the literature, but all this thing is happening to establish a full circular economy. This is again I am repeating the website, you can have a look, and if you have any questions you can contact those people and they will be happy to answer your queries. Yeah. So, with this completes your valorization of shells and crustaceans. Now, the question was yesterday whether we go for demineralization or deproteinization. Demineralization or deproteinization, which one is the best one? First we should remove calcium or first we should remove the protein? In your opinion, what is the best? Do not worry about this standard data. So, the work which was carried out here, deproteinization first, chitin yield, and then creamish white, demineralization, this one, that is chitin produced through DPM sequestration, that is deproteinization followed by demineralization, demineralization followed by deproteinization. I said other way around, you can see differences in the color and standard chitin. Which one do you think is the best? If you say A is best, then why? The simple stuff is, what is easier to do first, deproteinization or demineralization? You should eat fruits first, or you should eat main course first and then fruits, or you should eat your what you call tiffin items first followed by the main course. Yeah. If you go in wedding parties, especially in the north, you have all those pani puri and all those type of snacks are there, then you have main courses there. Some people they eat main course, then they go in sweet dish. Yeah. Some people they go first in a sweet dish followed by the main course. Yeah. So, similar type of approach is here. The reason is why most of the cases demineralization is done first, so that you are reducing the volume, yeah, and stiffness of the material. But if you are grinding it, then it does not make a difference whether you go for deproteinization or demineralization. The purpose of demineralization directly is, if you are able to break the shells or by using acid, it makes things easier then. Yeah. Okay. So, both the processes are applied here. Second thing is, deproteinization is done first in some cases when you are not using advanced technologies. Yeah. If you are using a microwave and you are putting in a shells in, because of minerals and all, it will cause a lot of spark and other stuff. Yeah. Any questions so far? Is it all clear or nothing is clear? Okay. So, how we can do complete shell biorefinery? Yeah. Shrimp, how we can clean these shrimp? Think you have bought a shrimps or any fish at home. First you clean it. Either you clean it with the normal water or chlorinated water, right? Chlorine containing water. Second one is sorting or grading. Then processing includes beheading, that is removing the inedible portion of shrimp. You peel it, cooling, and you get shrimp meat. Yeah. How difficult is to get shrimp meat when you have shrimps from there? It's quite difficult to remove the shells from the shrimp. Yeah. Think of the lobster, it's even difficult. So, if the moment high pressure is provided to these samples, high pressure processing to certain pressure, it becomes easier to remove meat. I will show you a very short video the other day. Maybe when we go for the processing, right. Then clean, dry, grind, you remove pigments. Yeah. What type of pigments are present in shrimp? Astaxanthin, and they are classified as carotenoids. Yeah. Pigmentation by using supercritical. So, what you get? Pigments and other lipid fractions. Yeah. Once you have this lipid fraction, leftover biomass goes for subsequent extraction of proteins and other elements. Yeah. So, you have this, remove it and you get your astaxanthin, right. Now, once you get your lipids, pigments and astaxanthin, leftover biomass is subjected for demineralization, washing, yeah, deproteinization by using alkali, washing, residual water, and you get your chitin. Yeah. So, this is a complete biorefinery of shells. Yeah. Do you think anything is missing from here, or is there any mistake in this process? So, once you have all this, and remember when supercritical CO2 is used, that is in tune of 100 to 200 megapascals, right. High pressure conditions are used to generate supercritical fluid extraction. That condition is also good for advancing or enhancing demineralization processes, because shells are already disrupted. So, all these steps, any of the technology done will have a subsequent effect. Yeah. So, you might conclude shrimp shells directly extracting chitin from here without having supercritical extraction, or with the supercritical extraction you have different recovery yields, is because of this can be considered as pre-treatment as well. Yeah. And by doing so, in supercritical CO2 extraction system, you are also able to reduce the microbial load or microbial contamination of these shells. Yeah. Now, this is what shows how we can use the whole shrimp for a number of different products. If I ask you to identify the type of product we can obtain from here, from this biomass, A is your food item, yeah, that is your meat. Yeah. As you can see with the color coding, this is meat production. Yeah. Second one is astaxanthin, yeah, pigment. You have chitin or chitosan and proteins from here. So, complete valorization of this will yield you A is food, B is your astaxanthin, that is nutraceutical or pharmaceutical compound. You have protein which can further convert it into peptides, that is your again ingredient, chitin, chitosan, for either for biopolymer application or for antimicrobial activity or for as an ingredient. Yeah, 5 ingredient. What else we can get? The minerals, which is again related to CaCl2, calcium chloride if you are using hydrochloric acid, calcium acetate, calcium citrate, and if you go and look into the market and you will see all these ones are sold as a separate entity. Calcium chloride is anti-caking agent used as a filtering aid. Calcium acetate and calcium citrate, they also have some other medicinal or medical applications. At the same time, calcium citrate, calcium acetate are also can be used as an ingredient for chicken feed, where you have to add calcium to it, or fertilizer. Yeah. So this makes your full biorefinery related to shells. So this shrimp can be converted to your fish or crab. Pretty much the process remains the same. The conditions will vary depending upon the biomass. Yeah. So this is your deacetylization and chitosan production. Now this is slightly complicated version of the previous one. Shells, astaxanthin, protein, calcium carbonate and chitin. This is what it is present in shellfish waste. Yeah. Drying and grinding, you use 1:20 of hydrochloric acid. Yeah. Here 1:10 was used, because this was supposed to be scaling up version. Our target is to reduce it to 1:5 so that we do not have too much of chemical there. But again, we are compromising with the quality of the end product. Centrifugation conditions. Yeah. So what is the difference between RPM and G-force? You should never replicate centrifugal technique based on RPM. Yeah. RPM can be higher, but G-force is the one which is to be replicated. Yeah. Do you know the difference between G and RPM? Revolution per minute. Yeah. If blade is a smaller length, in 1 minute it will do how many rounds, right? If blades are smaller, in 1 minute it will do more RPMs. Yeah. RPM means point to point. If you have this circle, this point, how many revolution it will take in 1 minute? Yeah. If you have a smaller circle, in 1 minute, this point will take how many rounds? Yeah. Compared to this circle. Yeah. This will take less number of revolution per minute compared to this one. Yeah. So RPM is not the one which is to be replicated. It is the G force, that is gravitational force. How to measure of the centrifuge? If you see the centrifuge, there is always a shaft. You measure the length of the shaft, and based on that G force is calculated. That is why the windmills, they move so slow and they produce large amount of electricity. They are low RPM, but their G force imparted is higher. Yeah. Okay. That is the difference. So revolution per minute or G force. If you would have published paper, always the first thing a reviewer will ask you to write a G force, not the RPM. Yeah. We do present RPM, it's just because we don't want to tell what was the G force. As simple as that. It's something like fan setting 4. That means what? Regulator setting 4 means nothing. Mixer grinder, regulator setting 3, isn't it? If suppose the mixer grinder is having only 2 regulator setting, high speed, low speed, those are no units. Yeah. So that is why you have to be very careful what you report and what is used. Then you have mineral rich astaxanthin supernatant. That is another reason why acids are used, because they are pretty much stable in acidic condition. That is why acidification. Then dilution, ultrafiltration system to get your calcium chloride, water, bit of hydrochloric acid and astaxanthin. Yeah. This is process number 1. Second, process number 2, after centrifugation, you have your pellet, This is pretty much what you have done. Yeah. Neutralize to pH 7. Now, why you were washing the shells yesterday after doing demineralization, you were washing it? Why?
To remove the excess acids.
If acids remain there, what will happen? That's correct, yeah?
Like it will react with the upcoming NaOH. So it is better to remove it.
Okay, that's correct. We wash the acid because so that when you add an NaOH, yeah, it doesn't matter, you may have to add additional NaOH. But the problem is the moment HCl is still present, if you are not washing it and you use NaOH, instead of 10 ml, you may need 15 ml, yeah, to get to that pH. So that is not a problem of having additional NaOH. The problem is it will form NaCl, yeah. When NaCl is formed, and this will precipitate along with your stuff. So your chitin purity will be impacted, yeah. So that logic was of washing was only to reduce the usage of NaOH. That is also not a problem because you are adding additional water, but purity of chitin or chitosan will be impacted, yeah. So any of the process, if you see it, even this process or any literature process, if you have the question of why and what has been done, why it has been done, then you will have your all the ideas clarified each and every step, yeah. So you should have at least 15-20 questions coming up with this particular process, yeah. If you ask those questions and they say there is no point in doing it, so we do as reported process and slowly we eliminate the steps so that we make it very simple process, yeah. Now, once it is washed, and remember when we wash it, this wash water can go back to this water because washing one will also contain certain amount of calcium and other salt, yeah. Sometimes when you do filtration, how many of you make tea with a tea, not with a tea bag, by use or normal tea, yeah? You boil it, you get your tea. The spent tea, if you boil it again, you still can recover some tea, right? So that means all the residual portion can be extracted out of it. So neutralize it to pH 7, filtration and drying system, then you go for deproteinization, yeah, and then same centrifugation, protein rich supplement and proteins obtained, yeah. Raw material, physicochemical properties and stuff related to input and output and what is economic cost associated with it, yeah. Then once you obtain a pellet, then you wash away alkali. Why you are washing the alkali here now? To remove extra proteins out of it. Then you get your chitin, yeah. Chitin is converted into chitosan, and chitosan is having good solubility in water, is just because deacetylation, that is strong alkali of up to 50% of NaOH, heated for 2 to 3 hours to get chitosan, yeah. And this is not a rocket science process. This particular process you can find it in a documents back to 1980s, 1990s, yeah. Okay. So the advancement done is how we add technologies at different point. So running this full biorefinery process will take at least 24 to 48 hours, yeah. To increase, to reduce the time of this to 2 to 3 hours, we change the concentration and we elevate the temperature. Usage of temperature, you have to be very careful. If you use very, very high temperature, the molecular weight of chitosan won't be high, which cannot be used for biopolymer application. But you can have low molecular weight chitosan, which are having lot of medicinal and pharmaceutical properties, called as oligochitosan, that is chitosan with a shorter molecular weight, or oligochitosan peptides. Peptides in the sense having a peptide, sorry, not peptide, short chain chitosan which will have other biofunctional properties for different applications. Yeah. So, this is what a shell structure looks like. So, whether you have blue crab shells or you have spider crab shells or any of those biomasses, yeah. This specific type of blue crab shells were opted from Italy because we have Italian partner working on the project, and they get this blue to get what type of pigments were present in it. So, since we were only interested in to get those type of pigment, we went through a classical way of doing the freeze drying. We wanted to preserve the bioactivity of those pigment, extraction, and somebody was talking about deep eutectic solvent the other day. Yeah, deep eutectic solvent in a simple way is the mixture of solvents to get multiple properties together. Yeah, that's the meaning of deep eutectic. It is not a special type of solvent. If you are having alcohol, acidified alcohol, that is one of those deep eutectic solvent. Yeah, it is a word which is used. What type of solvent is water? Yeah, water is also a solvent. Yeah, and solute. Yeah, definition is solute and solvent. Solvent is any liquid which is used to dissolve solute. That's it. Yeah. Now, deep eutectic, that does not mean is a special type of a novel solvent. You have to buy it and do it. You make your own one. There are multiple number of combinations are there. Acid with choline chloride or with cysteine, they all have different properties which improves the extraction efficiencies. So, that is the only difference between a single solvent or combination of those solvent. So, this one, and then different techniques by using either ultrasonics or extraction. Now, these are the things what you have to work on. Extracting solvent, combination of natural deep eutectic solvent, or if you look into the literature, you will see, oh, I will use Nades solvent. Yeah, you know, is not tennis player Nades. Yeah, it's just natural deep eutectic solvent. The beauty of scientific research is lot of different types of abbreviations and names are used which are often which confuses people. Not confuses, we get intrigued about it. Yeah. The thing is, if you are able to understand, you think, it's easy. Yeah. For you all, clearing 10th board exam, how difficult it is now at this stage is easy because you have done it. Yeah. It is easier if you know it. So, it's better to understand in the simplest language and then to increase your level of knowledge. Then here you have astaxanthin, all these activities, high perform HPLC, or you have liquid chromatography to do the characterization. You go for FTIR, which you will be doing a demonstration, or you go for DSC to characterize all those biomasses, you know, in different by different techniques, so that every process is completed. Yeah, and then cytotoxicity, biological activity or bioactivity. Yeah. So, you can make things complicated from primary processing, secondary processing, all the way to tertiary processing. Yeah. Now, if you will see this particular process, slowly I have to bring in now the technology, because subsequent lectures are going to be the technology, so that you are able to make a link from the previous one. Yeah. This is ongoing experiments, ongoing work at the moment. Shrimp shells, hydrochloric acid, wash water. Yeah. Instead of using 1:20 straight away, first to use 1:5, take it away, use another 1:10, take it away, so that you are not building the concentration in it. Yeah. So, number of times you can do the extraction. Instead of doing one single extraction, you can do it multiple times. Something like you are drying your papadum or papad, leave it at one point, it takes longer. Turn it around, it takes less time. You are drying clothes, you keep turning upside down. Wheat drying, you keep churning it around, so it dries faster. Very similar protocol here. Yeah. So, instead of going for 24 hours, we can reduce time significantly. Alkali, and you get your chitin. So, even the conventional process was improved by using different combination of it. A. B. Instead of doing couple of hours with ultrasonics and microwave together, this was a specialized equipment which I will show it to you in maybe tomorrow when we go through a new technologies. Is specialized type of equipment which was designed, and within 10 minutes whole the process was done within 1 hour. Yeah. So, that is the place where we use the technology to improve processing efficiency. Yeah. And as you can see, these are different colors of the product, what is obtained, and raw material, ash content and protein content. Conventional, ultrasonics and microwave, recovery yield. Yeah. So, you are able to reduce the process in a shorter duration. So, this is the way it shows how we can use different technologies to improve the processes. Now, any questions or any suggestions or anything related to shells? Yes.
Sir, if we use soft shells instead of hard shells, can we get the same amount of chitin?
Soft shells means which one?
These crustaceans like crab and shrimp lose their hard shells, right?
Yeah.
Sometimes. So if we use their soft shells, will they have the same amount of chitin as hard shells?
But why it will have a soft shells? The certain varieties they have a soft shells. Yeah.
No, they lose their hard shells at a time.
Yes. Yeah, they lose because of demineralization, and that is one of the problem of environment because of changing the pH of sea water, and the shells are not as strong as they should be. Some of the chickens, they have very hard shelled egg because their diet contains lot of calcium. If they are deficient in the calcium, the shells are weaker. Yeah, but the chitin, chitosan will be there itself. That will be there, and again it has to be investigated how much you are going to get. So, the whole problem with the climate change is acidification of oceans. Because of acidification, the shell's strength is not as much as it should be. Very similar, if you do not have too much of calcium diet, your bones will be weaker. Yeah, but protein and other content will be the same. Yeah, so this is very similar. You will get similar one, but it will be very difficult to say unless and until we identify how much chitin or chitosan is there in raw material, and the whole of this biorefinery depends upon your recovery methods and how much you can recover. So, if shells in biomass contains 10 grams of chitin and you use all different extraction technique, as you can see the recovery yield, yeah, if you are able to recover all 10 grams, your recovery yield is 100%. Yeah. Whereas some are not recovered, based on that you calculate your purity, recovery yield and extractability. Yeah.
Thank you, sir.
Any other question?
Sir, from this table, why we get zero amount of ash content from conventional method?
Okay. Now, in this particular one, 0 nicely spotted, that was never measured, so it was not required to have a 0. I wanted to see, I just add some number, I already told you that I will leave some of the mistakes, yeah, to see how many people are spotting it, how many are not spotting it, yeah. 0 means nothing here, it was something like a blank here, okay. It was not estimated, only thing was to compare because already done to see this, there is no, it cannot be 0, yeah. Okay. It was just added in, I added this 0 this morning, okay, that is good. So, you are awake. Yeah. So, basically when we compare with different methods, and moreover when you are able to demineralize everything, yeah, when this is basically to find it only related to the protein. When you get 100% demineralization, it has to be 0. but it will not be 0. And as you can see, if you add this part, oops, if you add this plus this, it makes it 100. Yeah, that means demineralization is not complete. If you remove everything, all the minerals are gone. Yeah, that means ash should not be there. Correct? What is the purpose of demineralization? Ash contains minerals. Yeah. So if you remove all the minerals, yeah, that means ash should be technically 0. Yeah. So, but it cannot be absolutely 0. It was some 0.02 or 0.03. I just deleted the rest of the word. Yeah. So this shows the conventional method what we are trying to improve with ultrasonics or microwave to have 100% demineralization, but demineralization was not 100%. Yeah. So the purity of chitin was not as great as conventional one, but the process was done in 20 minutes compared to 8 hours or 6 hours. Yeah. Did I answer your question? Any other question? There is a logic, if you can't convince, confuse them. Yeah, sorry.
Sir, whelk shells and other crustacean shells are differing in chitosan content. What about the composition of oyster, clams and mussels?
Okay. Oysters, scallops and all those shells, they have different levels of proteins, chitin, chitosan and calcium content. Yeah. So first thing is, did not investigate almost on all the shells. Yeah. That could be assignment for you to do all the shells. The first thing, if you see the establishment of biorefinery, to see the biomass, what all it contains and what are the value of those ingredients, and then to establish the process. Yeah. Okay. So they all contain, pretty much every shells, they contain some amount of proteins and a calcium network. That's why they have a harder shells. Yeah. And if you cannot use it for food purpose, one of the best application of these shells are also to make a biomaterial, that is, which can be replacing ceramics as well as cement as well as a construction material. Some of our collaborators in Queen's University Belfast and other, they are using it as a filler material for construction. Yeah, because these shells can also be used for making construction material. So that's one is to see the composition. They all have different varied level of composition, and if you open any standard book or any standard paper, you will see all those composition. That again depends upon the variety, as your colleague mentioned about soft shells, where they are grown. If they are coming from the deep water, they have harder shells. If they are grown in less nutrient, the same thing like a wheat crop may have different amount of protein content. Yeah. Same thing, all the shells, they have a different composition, and whatever is their composition, and depending upon that composition, you are going to get your final product. So what we covered here was basically some of the repeat of the biorefinery processes. You have a raw material, then you have a process, and then you have end product. Yeah. So the end product, what you get, now comes the next question. What is the quality of those end product? Yeah, as you have seen here, how it compares with the commercial one. If you are growing crabs only to obtain a chitosan from a crab, you are not interested in meat, because some of the bigger businesses, every business does not have a food angle. They throw all those meats. They only use it for chitosan production, because chitosan is commercial processes and provides significant amount of money compared to the food itself. Yeah. And that is why if you will see the waste hierarchy, is the feed energy is the lowest one, well, disposing it is the waste, least one, then you have energy, then you have food, then you have feed, then food, pharmaceutical, cosmeceuticals. Yeah. So that particular triangle. So lot of places, all these shells are grown only for the production of chitin or chitosan, and this is going to go more and more, because these chitosans are going to be used for making biodegradable polymeric material, like what we use PLA film. How many of you know about PLA films? Polylactic acid Coming from where? Lactic acid. Lactic acid is a part of yogurt production. 40 years ago, who thought that lactic acid will be used for polymer? Yeah. Since chitosan, they are long molecular weight compounds, they can be used to make a packaging material which are very durable, strong, as well as can replace your single use plastics. So that's why the more and more emphasis are going on side stream. So if you take full biorefinery approach, you solve not only the food problem, but also tick boxes for every sector. But remember, you cannot establish a full biorefinery that you want to do a PhD on biorefinery of shells. Then you have to see each and every unit operation before you talk about the full biorefinery. Yeah, you know, one single experiment itself optimizing chitin production. Then you have astaxanthin. Then you have a protein. Yeah. So there are number of PhDs has been completed, number of postdocs they have completed to establish one single biorefinery for seaweed. It took almost 5 to 6 years to have a full biorefinery established with the seaweed, which we will cover in a next lecture.